And here we go with type 2 partial fractions. We've got repeating linear factors, and of course, how do you tell this? You factor it, and if there's, something like this guy in place saying we've got two of these exact same linear factors, well, it's type 2, repeating linear factors. And not much changes, I'll be honest with you, because you'll see here, as soon as I set up the partial fraction, squared equals, you still do the a over, but you start with x minus 1. You take one of the factors, and you add another one with the squared on it. And if it was cubed, for instance, you put plus c over x minus 1 cubed on the next one, and d over x minus 1 to the 4. Whatever, however many there are, you just kind of keep going. So if there was another factor in here, like I'll say x plus 2 in the bottom, you just have a plus c over x plus 2 as well. Like, you just keep doing your normal thing. Everything from this point forward is identical to type 1. Okay, so let's do that. Let's multiply everything by the common denominator again. X minus 1 squared. Well, that cancels everything out to 6x minus 11 equals a times x minus 1, because only one of the x minus 1's cancel, plus b. So I've got 6x, when I simplify it, equals ax minus a plus b. Almost kind of seems easier, well, this specific question anyways. So if I deal with my x's, I'll just do it right here, and my constant, we'll take it over to the next page right away. I get 6 equals a, and I get negative 11 equals negative a plus b. So that's just dealing with the coefficients of each of those. So, well, we know we've got a already, and we can go get b, because that's negative 6, add that over, and we get negative 5, using a little bit of mental math. So here we go now. When I plug in our numbers here, a was 6 over x minus 1 plus the integral of negative 5 over x minus 1 squared. I'll take those constants out. I always like having them out front, so that I'm just dealing with pretty straightforward integrals. 1 over, I guess I always forget the d of x, but don't forget your d of x, especially next year. I'm sure some professor will be mad enough at you that they'll whoop you. Well, here it is. We got our linear function, we got constant on top, so we already know what that one is from type 1, our cheater method. Ln of x minus 1 divided by 1. Okay, good. This one is a little bit more involved. We've got to use substitution on it just because. So here, I'll do it in a different color. U equals x minus 1. Du equals 1 dx. I guess I'll put our dx's in here just so that it's there. Oops. Dx. There. So when I go do this one now, I get negative 5 integral of 1. I'll say u to the negative 2 du. And now I can quickly do that in my head and substitute back in. So we get negative 5. Well, I guess it'll make it plus 5 because we're dividing by a negative 1. So plus 5 over x minus 1. And then plus the constant. So, of course, you can go do that work on your own. You just finished the whole assignment on substitution, so I'm pretty sure you're comfortable with it. And that's the type 2. So you just kind of keep writing it out as we did here. A, B, and then if there's a third one, C, D, so on and so forth. Hope you don't find that too complicated.